Okay, welcome. So this is the week 4 webinar of the class. So we're not at the beginning anymore. Now we're, delving deep into the class. So let me tell you the plan for today. As always, I'll be happy to answer any questions that you have. And that could be about anything. And then after that, we'll talk about the standard normal distribution. It turns out the normal distribution is the most important distribution of all distributions. So trust me on that one. And we'll see why, not this week, but next week, we'll start seeing why. This week, we'll just talk about the distribution. Then we'll see how do you calculate probabilities and percentiles from the standard normal distribution. And then after that, we will look at the general normal distribution. And again, that's not supposed to mean anything to all you yet, but we'll see what the stuff means in a little bit. And we'll also talk about calculating probabilities and percentiles from the general normal distribution. And that's going to involve a calculator. And then I'll do some applications. As I did mention, there are a lot of applications, but the reason why there's a lot is not going to come for another week. And that will be the plan. So a couple things. One is this might be a bit shorter than normal. We'll see. All depends on how it goes. But it's an important chapter 6, but it's not that difficult. One of the reasons why I make it not this week not that difficult is you should be working on your project. I want to let you know because I'm actually going to be gone in a week or so. And so if you need help from me, it's going to have to come by Sunday. Okay, will be the main helping. So the deadline for you to submit your draft for the project will be this Sunday. And that's the draft. That's not the final project submission, but the draft of the submission. So that's really important to note that. And I realize that I have a conference to go to the following week, so I will be gone. So you're going to have to, ask questions early, or I won't be around to help. Kyle will be there, and the tutors will be there. But, if you want help from me, you're going to have to submit that draft a week on Sunday, by Sunday morning, so that I can actually read it, because I'm leaving on Tuesday and it takes me a day sometimes to read them all. So it's really important you get that done. I've noticed some of you have already posted on the project discussion board your ideas, which is great. I recommend all of you take a look at what people have posted and my comments to see what works and what doesn't work and what some of the issues might be, so that you don't get stuck and fall into any of those issues. So that's a big suggestion for getting through the project. At this point, the hope is you have your project idea, you collected your data, and for the next 5 days, you should be writing it. Okay, and getting that project written. There is no new statistics we're going to be doing in this class that you need to know to be able to do well in the project. So that's a big thing. So that's a big deal, is the project. The other thing that you should think of, which is also important, and this is the 4th week of class. This is week 4. And week 4, what's important about the number 4? What's important? Why did I just say this is week 4 and that's important? Yeah, it's an even week, and in even weeks you have exams. So there is an exam this week. So you should do it. You must do it by Sunday. I recommend trying to get it done by Friday, so that if things go wrong, you get a couple extra days to make it happen. And if things go wrong by Friday, you can ask for extensions. Extensions can only be given if you ask by Friday, because the idea is the goal should be done by Friday, and then you have like a 2-day extension after that. That's kind of how this works. So hopefully that makes sense. So are there any questions at all about anything? Any questions? Okay, so if there's no questions, then we're going to get into the normal distribution. So remember, last week, we talked about the uniform distribution because you could actually calculate area using base times height. So, but I also mentioned that uniform distribution doesn't happen all that much. Okay, the whole point of it was to really understand what distributions are, not because the uniform distribution is the important one. On the other hand, the normal distribution, that's the biggie. So let me show you kind of a picture of it. And this is a picture of what's called the standard normal distribution. And it's got a few things. One is that it's bell-shaped. So it starts low, comes up high, and then goes back low again in a nice smooth way. The standard normal distribution has its mean and median, by the way. It's symmetric, so the mean is equal to the median, right at 0. And the standard deviation turns out to be 1 for the standard normal distribution. And basically, those are the easiest numbers to get because it's nice to be centered at 0. Standard deviation can't be 0, by the way, because then it wouldn't be a normal distribution. It would just be all only zeros. So to make it, sparse out, you need to have a standard deviation, and 1 is the easiest number. So this is a picture of it. And this is the empirical rule, which we talked about, I think, in week 1, actually. And that is for the normal distribution, approximately 68% is between -1 and 1 for the standard deviations from the mean. And if standard deviation is just 1, then it's between -1 and 1 if the mean is 0. And 68% will be in that region between -1 and 1. Okay, that is going to be the area of that region, which there's no way in the world you're going to be able to come up with that area using some kind of formulas and equations. Instead, it's one of these you just are supposed to know, or at least have it in your notes, that 68% of all the data, which means the area, is between -1 and 1 for the standard normal distribution. 95% is between -2 and 2. And 99.7% is between -3 and 3. Any questions on the picture? Okay, notice by the time you get to -4, it almost looks like it's gone down to 0. And it's really close to 0, but it's not 0 yet. And it never actually gets to 0. It just gets closer and closer and closer and closer, like minusculely closer. So just let you know that that's really important. All right, so based on that, the idea is let's see if we can answer some questions. Okay, so let's suppose Z follows a standard normal distribution. We're going to use the empirical rule, which is these numbers, which is 68, 95, 99.7. Find the probability that Z is between -1 and 1. So the first thing you usually do is you write Z tilde, just like we did for uniform distribution, but now it's a normal distribution, so we write N for normal. And that says Z has a distribution that is normal, and then there's going to be 2 numbers we're going to have to put in. The first number is the mean. In this case, the mean is 0. And the second number is the standard deviation. So when you have a normal distribution, the first number is the mean, the second number is the standard deviation. In this case, it's 1. Remember, if you have a uniform distribution, the first number is the left and the second number is the right. So it really changes with normal. Okay, this is a really easy question. What is the probability that Z is between -1 and 1? See if you can put in the chat box what that probability is, and the hint is it's very easy. What is the probability that Z is between -1 and 1? It's not 1. Look at the picture. That's the hint. It's really easy if you have the picture. So what's the probability that Z is between -1 and 1? Yeah, 68%. And usually you write that as 0.68. Any questions on answering that question? Do you agree that's really easy if you know how to look at the picture? Hopefully you see that. All right, so now it's going to get a bit harder. What is the probability that z is less than 3? So that, here's 3 on the picture. We want to be less than 3. Does that make sense? And that one's a little harder. So what we do know is that between -3 and 3, that's 99.7% or 0.997. But then there's more. There's less than -3. So let me write that out. So that's going to be the probability that z is between -3 and 3, plus the probability that z is less than -3. There's a few ways of doing it. This is one way. Equals. The probability that z is between -3 and 3 from the picture is 0.997. Any questions so far? All right. So now we need to look at what about less than -3? It's going to be very small. And the idea here is that if the inside between -3 and 3 is 0.997 or 99.7%, then how do you get the outside percent? If the inside is 99.7%, then how do you get the outside percent? It's quite easy. Do you remember how to get the outside percent? So one way to think about it, if you have an 80% chance of winning, then what's your percent chance of losing? If you have an 80% chance of winning, what's your percent chance of losing? 20%, and the way you get that is you take 100% and you go minus 80%. Similarly, we're going to take 100%, but now we're going to subtract 99.7%. Okay, and as a decimal, that would be 1 minus 0.997 or point. So let me write this out. I'm going to put parentheses here. 1 minus 0.997. But that would give us the entire outside, which is both the left and the right. And we only want the left. We want this less than -3 stuff. And it's symmetric. So the left and the right are the same. So if we only want the left, we need to divide by 2. Any questions on that idea? Any questions? Okay, so the rest is very basic. I just take that. Easiest is copy and paste. I'm going to copy. I'm going to paste it right into the browser. Hit enter, and there we go. 0.9985. Any questions on that idea? Okay, so now let's look at the next one. Find the probability that z is between -1 and 2. And the idea here is we're going to do something really similar. We're going to say, well, we know the probability between -1 and 1. So that's going to be equal to the probability that -1 is less than z is less than 1. Plus, so we know that piece, and that we've just now covered between -1 and 1, but we still have this 1 to 2 stuff that we haven't covered yet, if we want to go between -1 and 2. So plus the probability that 1 is less than z is less than 2. Any questions on breaking it up into two pieces? Not too bad. That is going to be equal to, well, probability between z is between -1 and 1. That's 0.68. We already did that. Now we need to find the probability that we're between 1 and 2. That's this stuff right here. So the idea here is if I want this stuff, what I can do is I could say, well, let's take between -2 and 2 and subtract between 1 and -1 and 1. And that will give me this piece here to the left between -2 and -1, and the piece between 1 and 2, but that gives me twice as much as what I want. So then I got to divide by 2. So kind of in summary, as I type it in, we're going to take the total area between -2 and 2, and that was 0.95. And subtract the area between -1 and 1, and that is 0.68. And then I divide by 2. Maybe I'll get rid of some of these open spaces so we can do it in one line. There we go. Any questions on that idea so far? Do you see the strategy? Kind of piece things together on what you know, put it together so that you can get all the stuff you know. And then you got to look at if you have left and right, you know, but you only want one side, divide by 2. Okay, then, very simple. I just stick in the calculator. And I get point. Did I get that right? I think I copied the wrong one. Let's one more time. Copy and paste. .815. Any questions on this one? Okay. Looks like you're understanding, which is good. Okay, so here's a picture again. Now let's do a different one. Find the value of z such that there is a 2.5% probability of being greater than this value of z. Okay. One thing that you might want to think about, let's say, you just met someone and you look at their height and there's a 2.5% probability of being taller than them. Are they tall or are they short? It says a 2.5% probability of being taller. Yeah, they're tall. So that means we're going to have a number that's out here somewhere on the right-hand side. Okay? So it'll be positive. Is that clear? Okay, so now what we're going to do is we're going to say, well, 2.5% chance of being bigger than that number. But again, that's just the right-hand side. We want right and left. The right and left, if the right-hand side is 2.5%, twice 2.5%, is 5%. Now that's the outside. So the inside has a 1 minus 5%. And 1 minus 0.05 is 0.95. Any questions on that idea? All right. Now, if you want to be You want the area to be 95% chance of it, then where must you be? And we're on the right, we're on the tall side. What's the value of Z from this graph? You see, here's that 95%. That's a hint. What's the value of Z if we're on the right side? Yes. So here's the 95%, and you go as far right as you can get, and you're right there. And that value of Z is 2. Any questions on that? Is that clear? Yep, the answer is Z equals 2. That makes sense? All right, so now let's do more. Very similar, find the 16th percentile. And remember, the 16th percentile means that there's 16% that are below you, right? That's what percentile means, right? If you're in the 16th percentile in height, you're short. Hopefully you know that, right? You're not tiny, but you're pretty short. So that means there's 16% below you. And then we do the same idea now. So if there's 16% below you, you're going to be over here, and your answer is going to be negative. You want to just keep in mind on that. Then we take 16, multiply by 2, so we get that below and above kind of the other side of the graph. And that's 32. And that'll be the outside stuff. For the inside, that'll be 100% minus 32. And that happens to be 68%. So what is Z? So what's Z? Yeah, Z is -1 because we're on the low side, and it's of the 68 percentile, 68% in between, which means we're at -1. Any questions on this example? Very similar to the last one. Okay. Let's do this one. So if Z equals 1.3, find the Z score. Okay, this one is so easy, it's weird. So what we do is we remember the formula. So I'm going to insert an equation because it's an equation formula. And we're going to have Z equals. Do you remember the formula for Z score? There's a fraction, that's a hint. Do you remember it? It's X minus mu divided by sigma. That was the formula for Z score. That is equal to, let's work it out. The idea is not hard. X is 1.3 minus mu, that's the mean. The mean for the standard normal distribution is 1. Sorry, 0. That's what I meant. And the standard deviation divided by the standard deviation, that's the 1. This is really easy. What is 1.3 minus 0 divided by 1? You don't need a calculator for this one. You should be able to get this one. What's 1.3 minus 0 divided by 1? 1.3. And there's our z-score. And that actually is why we use the letter z for the standard normal distribution. There's nothing special about 1.3. I could have chosen any number and I would have gotten whatever I started with. Because you subtract 0 divided by 1, you didn't do anything. Any questions on that? So that's why we use the letter z for the standard normal, because it is its own z-score. Okay, so now we're going to get a different one. Let's suppose x follows a normal distribution with mean 114 and standard deviation 23. So now it's not a standard normal, because standard normal, the mean has to be 0, and the mean has to be 0 and the standard deviation has to be 1. And that's not what we've got. So what I can first write, and it's a really good idea, is write x tilde n for normal, parenthesis 114 for the mean, comma 23 for the standard deviation. All right, so the next thing we're going to do is we're going to find the probability that x is between 100 and 120. Okay, and I will let you know this is very different than the ones we just did. There's no way you're going to be able to come up with this one just with quick little calculation. Okay, instead, you're going to need a calculator. Any guess what calculator number we're going to need for this? Yeah, here we are, normal probability. By the way, last week we did binomial probability. We do things in order. So we need the normal probability calculator. So I'm going to click on that. And notice what it says is fill in all the values except one below and hit calculate. Then the last value will be given to you. And we have low, high, mean, standard deviation, and p. So let's go back. For this part A, what is the low? If x is normally distributed between with a mean 114 and standard deviation 23, and we want the probability that x is between 100 and 120, what's the low? It's not tricky. Yeah, it's 100. What's the high? Yeah, 120. What's the mean? Yeah, 114. What's the standard deviation? 23. And guess what? We're supposed to leave one blank. That's good because we want P. So 100, 120, 114, 23. So 100, 120, 114, and I think it was 23. Let me double check. Yep. I leave the P equal blank and hit calculate. And there it is. The probability is about 0.3315-ish. Okay. And by the way, a picture is shown. And you can kind of see what's happening. We have the mean is 114. We want a probability that we're in between 100 and 120. And it is colored in red. So it's colored out. And it shows you the probability. Any questions on that? Yeah, so once you use this, it's not that hard. That was 0.3315. Find the probability that x is greater than 200. What's the low? What's the low? Not sure. Not X. This is, you want to think about what is the biggest number that's greater than 200? I sorry, smallest number. What's the smallest number that's greater than 200? Okay, everybody thinks it's 201, but that's not true because how about 200.1? Or how about 200.01? Or 200.000001? Okay, with a continuous distribution, you could go as far out as you want, and it actually doesn't even matter if you have greater than or equal to. You get the same answer. So we can write 200. Whoops, 200. Any questions on that? Any questions? All right. What's the highest number greater than 200? Um, let's see, 200.1. How about 300? 300 is bigger than 200. How about 500? Can you think of the highest number greater than 200? 1,000 is bigger than 200. There's a lot of numbers bigger than 200. What's the biggest number bigger than 200? It's kind of tricky. Any thoughts? I don't see you jumping in. Okay, it's actually infinity, but infinity is not a true number. So the idea is for the normal distribution, as long as you're many, many, many standard deviations away, after that, there's like not any significant amount of anything. So what I recommend is look at all the numbers. We have the mean, the standard deviation, and we have this 200. And put a number with nines and put a whole another digit after that. So notice the biggest number here is 3 digits. So make a 4-digit number with nines, and that'll be close enough to infinity. Okay. Any questions on that? And you can do more if you want, but at least an extra digit. The mean doesn't change. It's still 114. And the standard deviation doesn't change either. That's still 23. So now we just plug in. So the low was 200. The high was a bunch of nines. Same mean and standard deviation, P we leave blank. And I hit calculate. And now it's a really tiny value, 0.00000923. Oops. Any questions on that? Oh, maybe I'll actually, instead of that, let's put it up here. That's where it belongs. There we go. Any questions on finding that probability? You shouldn't be surprised it's really small because notice that the mean is 114, the standard deviation is 23. It's going to take pretty many standard deviations to get up to 200. So it's pretty many standard deviations away, and that has a very small probability. Any questions so far? Okay. The next one, I'm just gonna, I didn't erase all the stuff because I want to just kind of walk you through it. Let's say you want a probability that x is greater than 105, given that x is less than 125. So that you can use as a formula. Probability of A given B is the probability of A and B divided by the probability of B. Probability of A and B means it's greater than 105 and less than 125, or it's between 105 and 125. And then divided by the probability of B, and that is the probability that x is less than 125. So for the numerator, the low is 105, the high is 125. The mean and standard deviation were the same. And when I calculated P, I got 0.3360. For the denominator, we want less than 125. So similarly, that negative infinity is the smallest number less than 125. So just throw a bunch of nines in with a negative sign for the low. The high is 125. And then the mean was 114 and the standard deviation is 23. And I got a p-value of 0.6838. I divided those, I think about 49% or so. Any questions on that idea? Okay, let's look at the next one. Okay, there's a lot of questions, right? The next is find the IQR. So whether you remember or not, the IQR was Q3 minus Q1. Do you remember the definition of Q3? Definition of Q3, not sure. Q3 was the 75th percentile? Yeah, or the third quartile. So that means there's a 75% chance of being less than that number. So now if you think about of being less than that number, negative 1,000,000 is less than that number. So you can go all the way down to a bunch of negative nines. So we can go negative and then a bunch of nines. The high is what we don't know because it's less than that number, which we don't know. That's the one we leave blank. The mean is still 114. Standard deviation is still 23. What's P? What's P in this case? The hint is we're talking about the third quartile. Yeah, 0.75. Any questions on that? So now I can go to my calculator. I have a low is negative and a bunch of nines. The high is what we don't know. Same mean, same standard deviation. And the p-value, the probability is 0.75. And I hit calculate. And what it gives us is about 129.513264. Rounded to the nearest whole number would be 130. Any questions on that? So we're not done yet. That was Q3. Was 130. Then we have to minus Q1. There's only one thing that changes. What's the only thing that changes if I want Q1? The highest of what we want. What's the only thing that changes? Yeah, P is now 0.25 instead of 0.75. Always write as a decimal, not a percent, by the way. That's very important. And you calculate. And there we go. 98.4867. I'll just round the nearest whole number. 98 in this case. On the homework or the exam, round it, whatever they tell you. If they say round to 4 decimals, round to 4 decimals. And that is 32. Any questions on that? That clear? Okay, so next, the middle 84% of the data is between what two values? Okay, that one we have to think about a bit. So the middle 84% is between what two values? So the idea here is we need to find out that. Well, the problem is we don't know this value, we don't know this value. Is that clear? So we do what we kind of did before is when we had a standard normal distribution is if you know the middle, then you can find out how much is on the left and how much is on the right on each side. So I can go left. If 84% is in the middle, how much is in the left, the far left? Any ideas? If 84% is in the middle, how much is in the far left? Okay, so you got the right idea, but not quite right because 100% minus 84% is 16%. But that would be left and right. We just want left. We don't want one of them. If 16% is left and right, how much is just on one side? Yeah, 8%. So left is 0.08. So now we're ready to get this plugged in. Same mean and standard deviation. Now the probability will be 0.08. The low is going to be 99999 again, and the high is what we don't know. And we calculate. And there we have it. 8% is less than 81.7. So that's the first thing. So the answer is 81.7. And, all right, well, if there is 8% on the left, that means there's 8% on the far right. Does that make sense? But now, for the far right, that would be this guy. There's 8% to the right. Now the low is what we want and don't know. So I'm going to empty the low or blank it out. The high will be way out here, which is a bunch of nines. Okay. And it should be at least 4 nines, by the way. I just hit 9 and held it, and it just kept going, which I'm good with. As long as you get at least 4. Any questions on that? Then I hit calculate. And you get about 146. Round to the nearest whole number. And there's the answer to that. Okay. I do want to give you a warning. It's a lot easier to watch me do it than to come up with all the ideas yourself. So, here's examples, but you're going to have to answer it. Okay. Watching me is so much easier, isn't it? All right. So now that's all of those types. Okay. Find the z-score for the value of x equals 117. This is actually quite easy. So z, again, I can even grab that other one I did. Copy and paste and adjust. Z is still x minus mu over sigma. X now is 117. Mu is not 0 anymore. Mu now is 114. Sigma was 23. And then we got to calculate that. And one thing to note is that it's not, what's wrong with saying 117 minus 114 divided by 23? What's wrong with that? A lot of people make this mistake, so I want to kind of give you a heads up not to make this mistake. This is wrong. It's the wrong order, kind of. It's order of operations is wrong. So the 117 minus 114 has to happen before you divide 23. And the way you make that happen on a calculator is you use parentheses. Now if I hit enter, I get the right answer, which is about 0.13. Any questions on that? So it's a mistake a lot of people make, so don't make that mistake. Okay, so now it's time for an example problem. Okay, an application. All right, so here it is. Suppose the time until you or your wife, if you're male, will give birth is normally distributed with mean 140 days and standard deviation 7 days. Okay? So the first thing is just write out the distribution. We could say x tilde n 140 comma 7. Any questions on writing the distribution? So if I ask you write the distribution, this is what I'm asking for. Better have that tilde in there. Okay, and if you speak Spanish, that's that thing you put over the N in an enye. If you don't speak Spanish, don't worry about it. Then it's just kind of shift next to the 1. Okay, any questions on how I got the distribution? All right, now comes the question. Your boss has just scheduled you or your wife for a business trip out of the country. Is that a good idea? Okay, maybe not. Okay. You or your wife leave today and will return in 135 days. Okay. Find the probability that your baby will be born out of the country. Any questions on the question? All right. What is the lowest number of days your baby could be born to be born out of the country? There's actually 2 answers to this that'll work. One is like real life and the other is not real life, but both work. What's the lowest number of days if you're leaving today for the baby to be born out of the country? Any thoughts? It's easy. That's a hint. You just stepped on the plane, getting out of the country. Now, the lowest number of days would be today, 0. In a couple hours, baby's born and out of the country because you just got there. Do you see that? Any questions on that? Okay, what's the highest number of days for the baby to be born out of the country? Yeah, 135, because that's when you return. At day 136, you're back in America. The mean is 140. The standard deviation is 7. We want the probability. So we go to the calculator. So I'm going to hit refresh, just make them all empty. So we have 0. We have 100 and, let me find that again, 136. We had 140. And the standard deviation was 7. Any questions on getting this in the calculator? Okay, and I hit calculate. There we go, to the nearest percent. It's about 28% chance, or 0.28. Would you be okay with this? Having a 28% chance of your baby being born out of the country. Remember, you want your baby to become president of the United States someday, and you have to be born in the country to be president. Okay, I wouldn't be okay. Okay, so here's part B. You decide it's too risky. Okay, and you want to negotiate with your boss. Sound good? And you want to ensure that there's no more than a 1% chance for the baby born out of the country. What day should you ask to be the return date? Any questions on the question? Okay. What's the low? That's pretty easy. What's the lowest number of days for the baby to be born out of the country? It's 0. You fly out and baby's born. Do you see? And that's out of the country. The high is what you want to find out, because what day should you return? That's what we don't know yet. The mean is still 140. And the standard deviation is still 7. P is what we now know. P is 1% or 0.01. Any questions on that? So I go to the calculator. The high was blank. P was the 0.01. Same mean and standard deviation, same low. And I hit calculate. 123.7155. So if you're going to negotiate, you're going to say, I need to return in 123 days. Do you see that? Because anything higher than that is going to have a higher than 1% chance. 124 will have a higher than 1% chance. So 123 days. Asked to return in 123 days. Any questions on that? All right. Okay, at least you can see the numbers. Okay. So part C is it's now 138 days later, and the baby still has not been born. Find the probability the baby will be born within the next 24 hours. So now you're given some information. The baby hasn't been born yet. This is a given problem. So this is the probability that it's in the next 24 hours. That's between day 138 and 139. 138 is less than X is less than 139. Given X is greater than 130, greater than or equal to 138. Because we're given the baby hasn't been born, that means 138 days. It didn't happen between less than 138. Any questions on reading the question and knowing this is what we want? Any questions? Okay. This, again, we had a formula for that. That was, I think I need to insert the formula. That was a fraction. And the numerator is going to be the probability of both happening. Okay, let's make it bigger so we can see it better. The probability of being both between 138 and 139 and being greater than or equal to 138, which means we're still between 138 and 139. Any questions so far? Divided by the probability of what's given, which is the probability of X is greater than 138. And just a reminder, whether it's greater than or equal to or greater, it doesn't make any difference for normal distributions. The edges don't matter, so I'm ignoring the equal. So that we'll find out. Let's pop in a fraction. Between 138 and 139, let's find that out first. So the low is 138. The high is 139. Same mean, same standard deviation. I want the probability. And that's 0.05565. Any questions? Probability of being less than 138. That means the low is negative bunch of nines. The high is 138. And now we want the probability. So I leave the probability blank. Hit calculate 0.3875 or so. And that's 0.05565. I can do scientific calculator. Divided by 0.3875. And I get about 0.14. 14% chance. Any questions on this? Okay, by the way, just a note, just for fun. Okay, if the mean is 140 days, what does that say in like easy language that most people understand? You know? Average, kind of, but let me tell you what most people say. If you see a pregnant person, what are you going to ask them about delivery date? Yeah, what do you do? The due date is the mean. That kind of cool? And just know it's not true anymore, but it used to be the standard deviation was 7 days. It's not anymore, and it's not normally distributed anymore either. There's a reason, and the reason is medical. And the medical reason is C-sections. So it doesn't, if you only look at natural births and pretend everyone would have a natural birth, then actually the standard deviation is 7 days. But nowadays with C-sections, everything's changed. So this worked better in the old days, way before I was born. Any questions on this application? Okay, and then it really was a normal distribution, and there was a standard deviation of 7 days. And then whenever you're expecting, that's your mean. So let's do one more example question. All right, so you have a store, okay? You have a shop, and it's an ice cream shop. Sounds delicious? Okay, and suppose the amount of ice cream that you sell each day is normally distributed with mean 950 ounces and standard deviation 120 ounces. Okay, so basically what you can do if you have a shop, and you should, is collect data. Look at every day how much you sell, and see if it looks normal, find out what the mean is, find out the standard deviation. There it is. And that's really important for owning a business, because once you've done that, then you can start making plans and understanding what you need to do. So part A, so first thing, by the way, is we can write X tilde N 950 comma 120. It helps to write that because we can always just look up and see it. Any questions on that so far? And that is how to write the distribution. Part A is find the probability that on a randomly selected day, you're going to sell between 900 and 1,000 ounces. So the low is 900. The high is 1,000. The mean is 950. And the standard deviation was 120. Any questions so far? And then we go ahead and put it in. So I'm going to hit refresh, so it just starts it over. So we had 900. We had 1,000. Okay, we had 950 and 120. And the probability is about 32% chance. Okay, so there we go. 0.32. Any questions on that? Very similar to the last one, but now it's ice cream instead of having a baby. That's really different, but the math is really similar. All right, so now in the morning, you took stock of your supplies and noticed you have 1,100 ounces of ice cream in your store. What's the probability that you're going to run out by the end of the day? Okay, this is very important, by the way, because remember, if you run out by the end of the day, that means customers are going to come. You're going to say, sorry, we're out of ice cream. And two things are going to happen. One is you're not going to make money off of them. And the other is they're going to go home and say, I'm never going back there again, and tell their friends not to go. So you don't want that to happen. So if it's a high probability, that's very bad for your business. So again, we say, what is the low? What's the lowest amount of ounces to run out? What's the lowest amount of ounces if you're going to run out of ice cream for this case? Yeah, not sure you got 1,000 because that's not a number anywhere, but it's 1,100. Might have been a typo. Yeah, what's the highest number of ounces to run out? That customers would want. And the idea is imagine the entire world coming to your place and wanting ice cream. So basically infinity. So basically you throw nines till you get a whole bunch of them. Okay. And you can do 5 nines if you really want. I think I did 6, but at least 5. The mean was 950. The standard deviation was 120. And we want to find P. So 1,100 and 99999. So that's going to be 1,100 to a bunch of nines. Same mean, same standard deviation. I'll leave the probability blank. And I calculate. Rounded to 2 decimals, it's 0.11, or about 11% chance. Yeah, you always want more nines because that'll make sure that you're at least 10 standard deviations above, which means that is there's no error at that point. So that's why you always have at least one more 9 than all the numbers you've got in terms of the total number of digits, the highest number of digits. So the probability was 11%. I guess I should write that. So, okay. You're probably not okay with that. So let's suppose you want to be 99% certain you're going to not run out of ice cream. How much do you need to have in the stock at the beginning of the day? Any questions so far? All right. The low is now what we don't know. The high is the bunch of nines. The mean is the same, 950. The standard deviation was 120. If you want to be 99% sure you will not run out, what should P be? The way I've done it. There's 2 ways of doing this. I'm doing it this way. See, P would be 1%. 99% chance you don't run out. There's a 1% chance you do run out. So that's 0.01. Okay. The other way to do it is say the low is negative 99999. The high is what you don't know, and then the P would be 0.99. There's two choices on this one. And they'll give you the same answer. So low we don't know. The high was a bunch of nines, but now P is 0.01. Same mean, same deviation. And our low is 1,229. Okay, and if you really don't want to run out, probably round up to 1,230. Oops. So keep 1,230 ounces of ice cream in stock at the beginning of the day. And that's how you make business decisions. You definitely want to, understand statistics if you have a business. Any questions on this idea? Okay, I do want to remind you, this is actually one of the easier weeks in terms of the homework. Okay, or I guess I shouldn't say homework because it's an online class, but everything's homework. But the chapter is not that hard a chapter. Most people do fine. It's not tough, which means you should really be focusing on your project. So spend your time on the project. That's really important. Okay. And that's why today is a shorter kind of discussion, which means our secret word is actually, I decided the secret word would be 3 letters instead of, it's an abbreviation, IQR. That's an I, not a 1, by the way. So it's IQR for interquartile range. And there's our secret word, because one of our examples, we had to find the IQR, which was one of the harder examples. So the secret word is IQR. Okay, so I do want to remind you, and I want to tell you something about the project. I needed to make a little bit of a change because if I didn't make the change, it wouldn't work for me because I realized I got something going on. So the project, you must send me your draft by Sunday, this coming Sunday at 8 a.m. Okay, I want to let you know a couple things. One is that a week from tomorrow, I am traveling to a conference. Okay, it's a math conference. And I will be pretty much off, okay, at the conference next Tuesday afternoon through Sunday night. So I'm not going to be around much. I'll be able to check my email here and there, and that's about it. I will not have office hours on after a week from tomorrow. So that's really important to note. In fact, pretty much the last time you'll hear from me on Zoom will be in next week's webinar on Tuesday. So if you have questions about the project, you really want, that you want to hear from me, you want those questions, especially if you need to Zoom it or you need to get me to do anything that takes a lot of time, like reading a draft, that has to be done, within the next 7 or 8 days. The draft has to be by Monday morning. Okay, I needed to change that by Sunday morning so that I can read it. Monday is my busy day also of teaching. So I only have so much time. So you need to send that draft pretty early. Okay, there's still a lot of time. I mean, that's, 6 days is a lot of time. You should be able to write a draft. Then I can read it and then get it to you. I'm going to be on the road on Tuesday and Wednesday, going far away. And then I'll be at a conference Wednesday, Thursday, Friday. Okay, and then I might have a little time on Saturday and I'll be completely on the road on Sunday. Okay, and when I'm driving, I do not check my email Just let you know that because I'm driving, it's not safe. I do not have a self-driving car, by the way. I'll be driving all day, so very important to understand my schedule is going to be rough, and I can't do anything about it because I got a conference I need to be at, and I'm one of the I'm not just going to the conference, but I'm actually one of the leads, the conference planners for this conference. So I have to do this. So sorry about that, but stuff happens once in a while. So hopefully you understand. I'll check email once a day, but that's about it. After a week from tomorrow. Okay, any questions about anything? This is a great time to ask. I'll also have office hours all week. I can answer questions. Any questions? Okay, if there aren't any questions, as I said, today's one of the easier days because we just have a single chapter that's easier, but the week's not easy because you have an exam and the project to work on. So you got a lot of stuff this week to do, but the chapter is not that bad. Any questions? If not, we can say good night too. Okay, great. Have a great night. I'm going to stop the share. And have a wonderful week. I'm going to stop the recording too.